I'm gonna be brief about this. This is my project called Superr, and basically what it is it's a virtual machine with a custom assembly language and a superoptimizer. I was inspired by this blog post by Austin Hunley, where he did the exact same thing but in Python, and I wanted to implement it in Rust. This is what the language looks like, very roughly. Mine just doesn't have commas. So this is what mine looks like. And when you run this, this is gonna print 8 by adding 5 and 3 together. So you can see it prints 8, and then it prints the memory after the program has finished running. So these are all the memory slots. There's 12 of them, and if you run the optimization algorithm and say you give it you say that you want at best 5 instructions, it's gonna basically it's gonna run the program, it's gonna get the output, so the target memory after the program has finished running, and it's going to synthesize programs which, when you run them, give you the exact same memory output. So for this program, I guess it's a bit harder. Actually, it's probably because I'm not running in release mode. You can see it's much faster. It tests about 3.5 million programs a second, at least with the exhaustive optimizer. But as you can see, it's not always efficient, so you can actually try to use the random optimizer, which has a different algorithm. It basically generates random programs rather than generating every single possible program. This has its ups and downs. For example, it's going to test the same program twice, probably, at some point, but it does test about 15 million programs a second on my computer. And depending on the program and the output, it might be better for your use case. But generally, as I said, I don't remember if I said it actually, this is generally useless because you can see it generated a better program. Because this is, the language is very limited, and that is by design, and also because I don't know how to design assembly languages. It's because, like, if you had conditionals or if you had loops, which we do have loops, we have a jump instruction, but if we make programs generate programs with jump instructions, they're gonna get stuck in an infinite loop. So I made it just not do that. It only works with programs which are completely deterministic is not the right word, but when you run them, it always gives the same output, and there's no input. Technically, you can make it take input, just you will have to test for every input. So yeah, this is basically program synthesis, but dumbed down and very naive, actually extremely naive. A better approach to this is SMT solvers, which Google has done with Superr, with an OU, and it also made it work with LLVMIR, which is super cool. I don't know if it's efficient, I haven't actually tried it, but I know that obviously SMT solvers are more efficient for this, because you get to encode your program in a mathematical way, and you have to solve that using some, I don't know how it works, some mathematical tricks, I suppose. Generally, this concept of a superoptimizer was introduced in 1987 by this paper, where they didn't even use a VM, they just used the CPU like an assembly, and they did pretty much the same thing, but actually probably more efficient than the way I do it. And yeah, that's it.